Today's video is on complemented lattice and this is related to the discrete mathematics. And in today's video I am going to explain what is a complemented lattice. See here, if L join meet 0, 1 is a bounded lattice. Here the greatest element is 1 and the least element is 0. And the lattice L is bounded between these two greatest and the least elements. An element A belongs to L. Then an element B belongs to L is called the complement of A if two conditions holds. First one is A join B is equal to 1 and A meet B is equal to 0. See here, A is said to be the complement of B if A join B is equal to 1 and A meet B is equal to 0, the first condition. See here, a lattice L join meet 0, 1 is called a complemented lattice if every element of L has at least one complement. So each and every element should have at least one. So using this complemented lattice definition, so I am going to solve an example here. See here, consider the bounded lattice D30 and the relation here is divisibility from the hash diagram. And we have to check whether it is a lattice, it is a complemented lattice or not. See here, so it is a complemented lattice or not, we have to check. See here, it is a divisibility. So the relation here is divisibility. See, this number is 30. So all the divisors are, so 1 divides 30, 2 divides 30, 3, 5, 6, 10, 15 and 30. These are all the divisors of 30. And here is an hash diagram. See here, the hash diagram is so simple. First, the least element I have started with 1. So 1 divides 2, 1 divides 3 and 1 divides 5. And again 5 divides 15 and 5 divides 10, and here if you observe 2 divides 10, 2 divides 6, so 6 divides 30, 10 divides 30 and 15 divides 30. Here the greatest element is 30 and the least element here is 1. So that's what I have written. The greatest element is 30 and the least element is 1. Now we have to check whether each and every element is having a complement. If each and every element is having a complement, then we say that the given lattice is a complemented lattice. And next, moving to this, so we have to check whether it is a complemented lattice or not. See here, D. So these are all the divisors of 30. Those are 1, 2, 3, 5, 6, 10, 15 and 30, and this is the hash diagram. Here the least element is 1 and the greatest element is 30. So what is it we have to show? If A join B is equal to, here the greatest element is 30 and A meet B is equal to the least element is 1, then we say that the complement of A is equal to B. So if this condition holds here, according to the definition, A join B is equal to 30 and A meet B is equal to 1. So let's get started, and here join. So it is, as these are the numerals, we have to take the LCM of these two, or else by seeing the hash diagram we have to take the least upper bound. See here, coming to this is meet. Meet is nothing but the GCD of the two elements here, and or else if you watch this hash diagram, so we have to select the greatest lower bound among these two. See here, so after finding this I'll show you all at glance, will get all the complements of the elements, and let's get started here. So from this hash diagram, so for 1 and 1, so what is the greatest, so least upper bound here, upper bound is 1. For 1 and 2, the upper bound here is 2. Carefully observe. So 1 and 3. So 3 is the upper bound. For 1 and 5, 5 is an upper bound here. And 1 and 6, see here, for 1 and 6, 6 is the upper bound. And for 1 and 10, see here, for 1 and 10, 10 is the upper bound. For 1 and 15, 15 is the upper bound. For 1 and 30, see here, this is the upper bound. So first one is clear, and the next one, among 2 and 1, 2 is the upper bound. So for 2 and 2, 2 is the upper bound. For 2 as well as 3, see here, they meet at the first point here, 6. For 2 and 5, see here, for 2 and 5, they meet at a point 10. So if you are feeling difficult in finding from hash diagram, so you can simply take the LCM of 2 and 5, it's 10. So for 2 and 6, so for 2 and 6, the upper bound here is 6. For 2 and 10, for 2 and 10, the upper bound here is 10. For 2 and 15, so this is 2 and this is 15. So they meet at a point here. See here, they meet at a point. This is 30. And the next one here, 2 and 30. So if you observe, this is 2 and this is 30. The highest element here is 30. And the next one, 3, 1. So among 3 and 1, 3 is an upper bound. Among 3 and 2, 3 and 2, the upper bound here is 6. Among 3 and 3, the upper bound is 3. And among 3 and 5, 3 and 5, they meet at a point 15 here. So this is 15. Among 3 and 6. So this is 3 and 6. 6 is the upper bound. And among 3 and 10. So this is 3 and 10. They meet at a point, or else the LCM here is 30. So the next one is 3 and 15. So this is 3 and 15. The upper bound here is 15. And the next one, 3 and 30. So this is 3 and 30. The upper bound here is 30. Got it? And the next one, 5, 1. See, coming to 5 and 1, 5 is the upper bound. And among 5 and 2, they meet at a point 10 here. Among 5 and 5, so 5 and 3. So this is 5 and 3. They meet at a point 15 here. So the next one here is among 5 and 5, the upper bound here is 5. And among 5 and 6, see here, this is 5 and this is 6. They meet at a point. First, they meet at a point 30, or else take the LCM of these two, 5 and 15. So this is 5 and 10 here. So the upper bound here is 10. And the next one, 5 and 15. So this is 5 and 15. 5 is the upper bound. So 5, 30. So among 5 and 30. So this is nothing but 30. See here, among 6 and 1. So come on, this is 6 and 1. 6 is an upper bound. Among 6 and 2. 6 is an upper bound. Among 6 and 3, 6 is the upper bound. Among 6 and 5, so this, here is 6 and here is 5. The upper bound here is 30. And the next one, among 6 and 6, 6 will be the upper bound among 6 and 10. So for 6 and 10, they meet at a point 30 here. So they meet at a point 30. And among 6 and 15, this is 6 and 15, they meet at a point at the upper bound here is 30. And this 6, 30, 30 is upper bound. And next coming to 10, 10, 1. So among 10 and 1, 10 is the upper bound. For 10 and 2, 10 is an upper bound. And next 10 and 3, the upper bound here is 30. See here, so this value is 30 among 10 and 6. 10 and 6, so this is 10 and this is 6. The upper bound here is 30. See here, among this one, among 10 and 5, see here, 10 and 5, 10 is the upper bound. So this is 10 is an upper bound. Among 10 and 6, so this is 10 and 6, so this is nothing but 30. Among 10 and 10, 10 is an upper bound. 10 and 15, so this is 10 and 15, the upper bound here is 30. And among 10, 30, so this is 10 and 30, 30 is an upper bound. And next 15, 1, so 1 and 15, so 15 will be the upper bound. And next one, 15, 2, so here is 15 and here is 2, they meet at a point 30. And next one, 15 and 3, so for 15 and 3, 15 is the upper bound. So this is the upper bound. For 15 and 5, so this is 15 and 5, 15 is an upper bound. For 15, 6, so 15 and 6, 30 is the upper bound. For 15 and 10, so this is 15 and 10, they meet at a point 30. So for 15 and 15, the upper bound here is 15. For 15, 30, so this is 15 and 30, 30 is the upper bound. Among 30 and all the elements, 30 is the greatest. So this is the least upper bound. So 30, so this will be 30, this is 30, this is 30, this value is 30, 30, 30 and 30. So among all these, the greatest lower bound here, so the lower bound among all the elements is 1. See here, as you can check also. So here, the next thing here is, so 2, 1. So if you see 2 and 1, among 2 and 1 the lower bound here is 1, and among 2 and 2 the lower bound is 2, among 2 and 3 the lower bound here is 1, among 2 and 5 the lower bound here is 1, 2, 6. So this is 2 and 6, the lower bound here is 2. Among 2 and 10, 2 is the lower bound. Among 2 and 15, so this is 2 and 15. So they meet at a point 1. And among 2, 30, so this is 2 and this is 30. The lower bound here is 2. And next one 3, 1. So among 3 and 1, the lower bound here is 1, 3, 2. So this is 3 and 2, the lower bound here is 1. Among 3 and 3, the lower bound here is 3. Among 3, 5. So this is 3 and 5, the lower bound is 1. Among 3, 6. 3 and 6, the lower bound here is 3. 3, 10. So this is 3 and 10, the lower bound here is 1. So this is 1. And among 3, 15. So among 3 and 15, the lower bound is 3. 3, 30. So this is 3 and 30, the lower bound here is 3. And next one coming to 5, 1. So 5 and 1, 1 is the lower bound. 5 and 2, 1 is the lower bound. And 5, 3, 1 is the lower bound. And among 5 and 5, 5 is the lower bound. Among 5 and 6, see here, among 5 and 6, 1 is the lower bound. They meet at a point, both meet at a point at element 1. So among 5, 10, so this is 5 and 10, the least element here is 5. Among 5 and 15, so 5 and 15, the least element here is 5, 5 and 30. So this is 5 and 30. Among those, the least element here is 5. And next coming to 6, 1. So this is 6 and 1, the least element is 1. Among 6 and 2, the least element here is 2. Among 6 and 3, 3 is the least element. So among 6 and 5, so among 6 and 5, they meet at a point firstly at 1. And next among 6, 6. 6 will be the least element. Among 6 and 10, so this is 6 and 10, they meet at a point 2 here. Among 6 and 15, 6 and 15, they meet at a point 3. And next among 6, 30, so this is 6 and 30, the least element here is 6. And coming to 10 and 1, so this is 10 and 1. So the minimum element here is 1 least element, and 10, 2. So here is 10 and here is 2. The least element here is, the lower bound is 2. 10 and 3. So this is 10 and this is 3. So here if you observe, they meet at a point 1. And next one 10, 5. So this is 10 and 5. Here the lower bound here is 5. And 10 and 6. So this is 10 and 6. They meet at a point 2. And here 10 and 10. So 10 is the least. 10 and 15. So 10 and 15, the least element here is 5. And 10, 30. So this is 10 and 30. The least element here is 10. And 15, 1. See here, among 15 and 1, 1 is the least element. Among 15 and 2. See here, 15 and 2, they meet at a, first they meet at a point 1. And among 15 and 3. See here, 15, 3. So 3 will be the least element. And next one 15 and 5. So 15 and 5, 5 will be the least element. And 15 and 6. So this is 15 and 6. They meet at a point 3. So they meet at a point 3. Among 15 and 10. 15 and 10. See here, the meeting point here is, the least lower bound here is 5. And next 15 and 15. 15 will be the least. 15, 30. So 15, 30. 15 is the lower bound. And among 31, see here, among 30 and 1, 1 is the least element. So here 1 is the least element. So among all these 32. So among 30 and 2. So which one? It is 2 is the least element. Among 30 and 3, 3 is the least element. Among 30, see here, among 30 and 5. So this is 30 and this is 5. So here the lower bound here is 5. Among 30 and 6. 6 is the lower bound. Among 30 and 10. 10 is the lower bound. And among 30, 15. So this is 30 and 15. 15 is the lower bound. And among 30 and 30, 30 is the lower bound. If you observe from here, so here is the greatest element here, and here is the least element. And coming to this, so here is the greatest element, least element, greatest element, least element, same position. 31, 30 and 1, 30 and 1. So 30 and 1. So here 30 and 1. If you watch carefully here, so there are some other 30s here and there is no 1 here. The least element doesn't match. Therefore, these are very few 30s which are matched with the least element 1. So we have to plot like this, and immediately we can say that the complement of 1 is 30. The complement of 2 is 15. The complement of 3 is 10. The complement of 5 is 6. The complement of 6 is 5. The complement of 10 is 3. And the complement of 15 is 2. And the complement of 13 is 1. So if you look at this composition table, so you can tell the complements of each and every element at one go. See here, so these are satisfying the property complement of 1 is equal to 30. How? According to our definition, A join B should be equal to the greatest element and A meet B should be equal to the least element. Here A join 30 is equal to 30 and A meet 30 is equal to 1 here. Therefore, we say that the complement of 1 is equal to 30, complement of 2 is equal to 15. See here, the complement of 2 is equal to 15. The complement of 3 is equal to, so what is the complement of 3? This is 30. So it's satisfying these properties, and complement of 5 is equal to 6, whereas 6 is equal to 5, complement of 10 is equal to 3, and complement of 15 is equal to 2, and complement of 13 is equal to 1. So these are all the complements of each and every element. So if each and every element has a complement, then we say that the given lattice is a complemented lattice. Please go through this video for once again if you don't understand, but this is the easiest process of getting each and every complement every time. And this is the composition table, this is the hash diagram. So this is these are all the divisors of 30, and this is so simple. So I request you to watch these videos, kindly go through the playlist, and almost all the topics are already covered. And please go through. If you really like, you know what to do, please subscribe to this channel, share it with your friends and pass it on. Thank you so much.